More than 6,000 planets. That's how many worlds astronomers have now confirmed orbiting stars beyond our sun. And at least a few dozen of them sit in the habitable zone, the region where liquid water could stay on the surface, not too hot and not too cold. Yet after 30 years of better telescopes and thousands of observations, we still have not found one confirmed sign of life on any of them. So if the right conditions keep showing up again and again across the galaxy, why do so many scientists now talk like alien life is basically a sure thing somewhere out there? Stick with this. The answer has less to do with one distant planet we haven't checked yet, and more to do with something that already happened on Earth. It started in 1995. That year, astronomers found the first planet orbiting a normal star like our Sun. Since then, the count has shot up fast. Kepler, TESS, and the James Webb Space Telescope have shown that planets form around most stars. Some systems, like TRAPPIST-1 discovered in 2017, have several Earth-sized worlds in the habitable zone. We have even begun studying the air around a handful of these distant planets. So that's the search so far. But if we're this good at finding possible homes for life, why hasn't anything living shown itself in the data yet? Except the scientists who study how life actually begins on a planet aren't waiting for that first clear signal from space to make up their minds. What if the strongest clue we have isn't something we spotted on another world at all? Let's look at Earth's own clock. Our planet formed about 4.5 billion years ago. Within a few hundred million years, oceans had covered large parts of the surface. And by roughly 3.5 billion years ago, living things were already here. We see it in the layered rock formations called stromatolites, built by mats of microbes, still preserved in Western Australia. That means life did not need endless time or perfect peace. It got going in, at most, a few hundred million years once liquid water and the right chemistry existed. And if that jump from simple chemistry to living cells can happen that quickly on one young, violent planet, what does that do to the odds on all the other young planets we now know about? On top of the fast start, the actual ingredients life uses are not rare. Amino acids, the building blocks of proteins, have been found inside meteorites that fell to Earth. The Rosetta spacecraft detected glycine, one of those same amino acids, in the dust around a comet. Telescopes have spotted complex carbon molecules in the giant clouds, where new stars and planets are still being born. These materials are drifting through the galaxy in many places we have looked. So the raw materials are common. The process that turned them into life on Earth did not take billions of years. But that's not even the full story, because even with all of that in place, we still have not seen clear proof from anywhere else. And some people read that silence as proof that life must be extremely rare after all. The truth is simpler. Finding life from light years away is brutally hard. The signals are faint. The distances are huge. We have only studied the atmospheres of a small number of exoplanets in real detail. Just last year, one planet made big headlines when certain gases linked to life on Earth appeared in the data. When other teams rechecked the same observations with more care, the signal was not strong enough to count as solid proof. That is normal in this kind of science. Every claim gets tested hard, sometimes more than once. What this adds up to is a quiet shift in how scientists see the universe. If life can start quickly once the conditions are right, and those conditions exist on many other planets, then simple alien life, microbes or something like the earliest life on Earth, is probably common across the Milky Way. Not cities or spaceships, just biology that got started and kept going. That would mean the galaxy is full of living worlds we simply have not had the tools to spot yet. NASA and other agencies are already planning the next generation of telescopes designed exactly for this job. Instruments that can directly study the air of Earth-sized planets around nearby stars, and look for gases that only life tends to produce in large amounts. In the next 10 to 20 years, we may finally have a real chance to test the idea. If the timeline on our own planet already suggests life appears fast once it gets a chance, what does that mean for how you see the next wave of space telescopes and what they might find? We have now mapped more than 6,000 planets outside our solar system, and the record written in Earth's oldest rocks shows that life did not wait around for perfect conditions or endless time. It crossed the line from chemistry to biology as soon as the water and the building blocks were there. So the real reason many scientists now treat alien life as something that is probably already out there is not one dramatic photo or a single confirmed signal from another world. It is the simple fact that the same starting line life crossed here billions of years ago is now sitting in front of thousands of other worlds we have only just begun to examine. Does knowing that simple life might be common across the galaxy make you feel more connected to everything out there? Or does it make you want to see the first real proof even sooner? If this made you look at the night sky a little differently, follow for more stories like this, and share it with someone who still wonders whether Earth is the only place where anything is alive.